Today on the 44th lecture, that makes the 4th lecture of 9th week, we are going to discuss on the cross-cutting technologies. In this, in terms of cross-cutting technology, we will discuss about what are the technologies that help in terms of integrating or as the name suggests, cross-cutting. So it integrates, it aligns, it links various other technology and techniques. So in a sense, we are going to discuss about the artificial intelligence as one of the newer technologies all of us have been hearing, using, and also along with that we will talk about the geospatial technology. This combines the remote sensing, GIS, GNSS, and also the IoT devices. And also the third one is the integration of these two, which we call as GeoAI. So that means geospatial technology and AI. So these two, or you say the combined one, including the three technologies we are going to discuss today in terms of the cross-cutting technologies. So across this we will discuss about AI, artificial intelligence, which is a cross-cutting technology and helps in terms of climate action as far as adaptation and mitigation are concerned. We will discuss about the AI tools, how it helps in exploiting and understanding in terms of various Earth system models that helps in terms of climate prediction. We also talk about the AI for renewable energy forecasting and grid integration. Friends, all of us know in terms of towards achieving the net zero and other climate related targets, one of the important things is that we need to achieve, or we need to move from non-renewable to renewable sources. In the last class we have discussed about these various energy sources such as solar energy, wind energy, and also the hydrogen. So now today also we will try to see that how AI is useful for renewable energy forecasting and also in terms of the grid level integration. The fourth is we will discuss about the applications of artificial intelligence for solar energy production. In the last class we discussed about the grid based things as far as solar energy is concerned, auto, that means battery connected, and in terms of the storage. So the applications of AI for solar energy production we will discuss, and also we will see what are the challenges in artificial intelligence for climate action and what could be the various solutions that can be proposed towards this. The fifth one is we will talk about the various geospatial technologies that are useful in terms of climate adaptation and mitigation. And finally, in terms of combining both geospatial and artificial intelligence, we will talk about the GeoAI, how GeoAI derives the synergy from both the tools, from AI tools, from geospatial tools. So in terms of that, we will see how GeoAI derives synergy for enhanced or to give higher or increased or enhanced climate solutions. We will also talk about how GeoAI leverages the AI's data driven intelligence. So this is actually what it does. It leverages the AI's data driven intelligence and the high spatial precision of the geospatial data. So that is how GeoAI derives synergy for providing us enhanced climate solutions. The first one is in terms of AI, it is a cross-cutting technology that helps in climate actions. It is a critical transformative tool useful in climate action by driving mitigation. How it drives the mitigation? It drives mitigation by optimizing energy grids, such as in terms of application towards renewable energy sector, boosting renewable efficiency, and identifying emission hotspots. As far as adaptation is concerned, AI enhances resilience through predictive modeling and also helps in terms of early warning systems. In the last class, we discussed about early warning system in terms of adaptation tools. So, early warning systems for natural disasters and also the precision agriculture. So, we say in terms of precision agriculture PRA, this also is one of the adaptation tools which means AI helps in terms of adapting as far as the precision agriculture is concerned. So, AI processes massive data sets. So, what is so one of the characteristics of AI is it processes massive data sets for better decision making. Coming to the key applications of AI in climate action is mitigation. So, first we are talking about the mitigation, that means reducing the emission. So, in terms of energy management, the first one, in terms of the energy management, that means management in energy sector is concerned, AI maximizes the renewable energy generation by forecasting solar variability or wind variability, and also by optimizing the power grid loads because it processes lot of data. Second is in terms of the smart systems. AI controls building energy use, it optimizes heating and cooling and also lighting, and thereby it enhances the industrial energy use efficiency by processing heavy data or you say large data. As far as the transportation or logistics are concerned, AI improves traffic flow, it optimizes logistics to reduce fuel usage and emissions. Coming to the fourth one, in terms of the carbon dioxide or carbon dioxide equivalent capture. So, AI accelerates material science, assisting in development of materials for CCS, and also it helps in processing the data as far as the various sources in terms of carbon capture, storage, and also the transport is or utilization is concerned. Moving on to the adaptation as far as the climate is concerned, climate action is concerned. Adaptation, as all of us know, it talks about adjusting to impacts as far as disaster management is concerned. So, AI enabled tools such as satellite image analysis, they provide early warning systems for early warning systems to boost yield under various changing conditions. So, these fall under smart irrigation, pest detection and all these things. Coming to the infrastructure planning, AI also helps in simulating climate scenarios to strengthen urban design, identify vulnerabilities to inform infrastructure investments. So, AI has significantly improved the predictive capacity, operational efficiency and adaptation planning in terms of climate related contexts. So, three things I mentioned. It helps in improving the predictive ability because it deals with large volume of data. It also thereby improves the operational efficiency and also helps in adaptive planning in terms of the climate action related mitigation and adaptation activities are concerned. So, the overview of AI applications across the climate change sectors are many. So, here in terms of the depiction as far as the central figure is concerned, you see on the top there is the AI, that means artificial intelligence and climate change mitigation. A kind of graphics has been given in terms of that shows or imitates the neurons with several connectivity as we find in brain. Coming to the first one, as we know, it enhances the energy efficiency or boosts the energy efficiency, helps in terms of carbon sequestration and storage. The second one, energy efficient building design and renovation. The third one is it also helps in terms of reducing the deforestation and thereby helps in natural resources management by processing heavy amount of data. The middle one is with respect to the sustainable land use in terms of early warning system, forecasting and extreme weather events are concerned. The next is optimizing the transportation systems. So when it is connected through satellite devices or IoT devices or through signal receipt and transfer, it helps in terms of managing the large fleets or large trucks, the transportation sector, including the community buses and the private or single owned cars. Coming to the sixth one is with respect to grid management, that is the grid management which helps or assists in terms of renewable energy forecasting, that where how much we can store, how much is the demand and how much is the what you say surplus or necessity. That way the grid management is done as far as the renewable energy sector is concerned. Coming to precision agriculture, so it is less used in terms of the fertilizer, chemicals and all other things. We know that where how much what is the situation in terms of the drought or in terms of the nutrient deficiencies or that kind of way we help our AI processes the data and helps in precision agriculture. Coming to the eighth one is the resilient cities for sustainable development. Through lot of sensor devices, lot of data are collected, are generated, processed and also analyzed. So that is how the AI helps in terms of the climate sector in various applications. So advances in machine learning, the AI, machine learning and deep learning tools in terms of optimization and data driven decision. It support across key domains. So renewable energy forecasting, energy system optimization, land use planning, disaster risk management, precision agriculture and also water resources allocation. So these are some of the important sources where we use the AI is applied for in terms of climate change related actions. Moving on to the Earth system models. Friends, all of us know that lot of data are needed in terms of the Earth system model. What is the Earth system model? As all of us know, in this picture or in the depiction, we can try to understand here the different components of the Earth system have been represented, have been depicted. The coming from bottom, the ocean bottom topography, the vertical over in terms of ocean, the topography, the overturning, the sea ice, the what you say ocean current, temperature and salinity, and also the heat salinity exchange and the wave and wind energy. So all these things are fed or in terms of lot of data, and that is done through artificial intelligence. And then coming to the biological system, as far as ocean is concerned, the biology, the diversity, all those things are also what you say depicted there. In terms of the geography of the system also has been integrated there. And coming to various other things in terms of the terrestrial, we have the lake and river system as the drainage what you say reservoirs and the channels. We also have different processes that are also being represented in an Earth system model, such as runoff based flow. On the other side, in terms of the human influences and the land use, which is represented in terms of habitats and the cropping or the other land use land cover patterns. And in terms of the land surface, we can also represent them in terms of the topography and the surface reflectivity. So the vegetation, the natural vegetation, the soil moisture, all these things are represented through data in the Earth system model, including the snow and glacier covers, which are there to stop in terms of the either of the poles or the top of the mountains such as Himalayas. And then then the various processes as far as the evaporation, transpiration, the transition to solid and vapor, the solar radiation coming from there. So that means incoming solar radiation, the outgoing heat energy, and also the cloud system also is represented in terms of various types of clouds and the atmosphere. So that means the Earth system, it represents various major activities in terms of structure and function to imitate the Earth in a digital surface. So that means how it is represented? It is represented through data. It is represented through 2-dimensional and 3-dimensional data sets. So that is how it represents various sectors, domains we call hydrological processes, the permafrost carbon climate feedback, the terrestrial ecology in terms of the carbon cycle and the phenology, the land atmosphere, the wildfire in terms of the solar radiation, also the radiation from sun is represented. The atmospheric models are also in terms of cloud, convection and microphysics. In terms of the atmosphere, also the gravity waves, the turbulence, the ocean or sea in terms of salinity, heat and momentum exchange. So what I mean to say, all these they form the various structural and functional component as far as the Earth system is concerned. So now what is represented here is the feedback mechanism across the Earth system that introduce uncertainties in climate projections affecting the carbon cycle and climate change systems. Now many feedbacks are poorly understood and are resolved. So the feedbacks are very poorly understood, many of the feedbacks, because of non-utilization of the AI and machine learning in terms of heavy data processing, which that means this calls for sustained research towards improved core scale Earth system models that explain the utility of AI and machine learning along with emerging data streams to help overcome the barriers to understanding and representing them in hybrid Earth system models. So what I mean to tell you that in terms of the Earth system models that represent various understanding and various processes including the predictions as far as the climate system is concerned. So the data heavy data heavy algorithms are coming through AI and machine learning that helps in terms of understanding the Earth system models better. So the interplay of natural processes and human induced emissions underscores the complexity of mitigating the climate change. That is what is necessitated in terms of innovating solutions such as artificial intelligence for effective climate strategies. So in nutshell, we need contribution from the by AI, which deals with lot of data in terms of analysis, so large data analysis in terms of artificial intelligence that helps in better understanding the Earth system models. Moving on to renewable energy and forecasting, as far as the grid integration is represented, AI enhances the renewable energy systems by accurately forecasting the solar or wind variability, optimized grid stability and reducing the dependency on fossil fuel backups. These techniques like machine learning and reinforcement learning such as RL, they analyze the weather and sensor data to optimize energy storage. Look at this, they analyze the weather and the sensor data to optimize energy storage, optimize energy distribution. That is how it significantly reduces the curtailment and also thereby improve the reliability of these grids. So, accurate forecasting, the grid stability and management, energy storage optimization, the reducing the curtailment. These are the four important things what AI based algorithm does as far as the accurate forecasting is required from from the renewable grid sector, renewable energy grid sector. So, the benefits improvement in efficiency and also it contributes towards cost reduction and also reliability enhancement. Moving on to the how it is exactly used in terms of the solar energy production. So, you can see the applications of AI for solar energy production connected by four things. The first one in terms of solar irradiance forecasting. How much is the solar irradiance in a day? Where you see in terms of lot of disturbances or barriers through cloud and other processes. So, that is how we get through AI algorithms that can improve the prediction of solar irradiance levels by analyzing the data in terms of historical and real-time data as far as weather data is concerned. So, that is how it allows the solar farm operator to better plan for the power generation and the grid integration. The second part is the energy storage and grid level integration. So, artificial intelligence can optimize energy storage systems such as batteries or thermal storage to store excess solar energy during peak production periods, and that is how it and also it releases it when it is needed. So, storage is required. So, that is how it results in a more reliable and consistent power supply by integrating the AI tools. Coming to the predictive maintenance, how much maintenance is needed. So, AI also can be used to monitor and analyze sensor data from solar panels and other system components that helps in identifying patterns and early signs of wear or malfunction. So, we get the indication in advance, or if it is predicted well using AI tools, that where how much malfunction can happen and when can happen. So, that helps in terms of the timely maintenance and also reduce the downtime as far as the energy availability is concerned. The fourth one is optical solar panel orientation and tracking. So, AI also helps in determining the best orientation and tilt angle for solar panels to maximize their energy generation. So, it helps in terms of which direction angle it can tilt. So, that is why it helps in terms of enabling a real-time tracking of the sun's position. So, that is how it improves the efficiency in terms of the solar energy capture. Moving on to the various challenges. The challenges in utilizing the AI in terms of climate action and proper solutions. The various categories are data scarcity. So, many times we AI are the artificial intelligence tools, they need heavy data. So, sometimes we are lacking the data. So, data scarcity is one of the challenges. That is also overcome by various by utilizing AI tools in terms of generating or generating, integrating or some pseudo data production mode. Going to model biasness, it helps in improving the model bias, energy intensity, water usage, transparency, fairness and accountability, dual use dilemma and governance. These are the various challenges the AI faces, and the specific issues are also mentioned there. The impacts are mentioned also there, but the proper solutions are many times it is local data infrastructure partnership is needed, energy efficient architecture is needed, sustainable Sourcing efficiency matrices are also useful, and also the purpose bound licensing and audits helps in terms of overcoming the challenge coming from the dual use dilemma. Coming from the governance sector, consent mechanisms and encryption also helps in terms of addressing the challenges as far as AI for climate action is concerned. Now let's move on to the geospatial technology. Friends, as all of us know, geospatial technology is integration of many technologies. It integrates the remote sensing, GIS, the drone, earth observation, LiDAR, the GNSS, and also the IoT devices. So thereby it helps in terms of addressing various climate change adaptation and mitigation issues. In terms of sea level rise monitoring, you get the data. Remote sensing helps in terms of giving you the data at a spatial scale. GIS helps you in terms of integrating the data, and also various other data sets coming from various other earth observation platforms that helps in terms of giving us the data on greenhouse gas emission, ocean temperature, snow ice melt, the various trends as far as the globe is concerned in terms of biogeophysical variables. Coming to the UAV and the drone usage, drone also helps in giving the data in near real time, and whenever we need, it is at our mercy to put a sensor on the drone, fly it over for certain purposes, for certain specific purposes. So that is how it is very well used in terms of disaster assessment monitoring, in terms of precision agriculture. LiDAR and other data sets, they help in terms of good carbon accounting from vegetation at the plants, and also helps in terms of urban related climate problems. So that is how it helps in terms of climate modeling, sea level rise modeling, carbon footprint mapping, biodiversity and habitat change, drought and water resources management, extreme weather event analysis, and also renewable energy planning. Now moving on to the next one, that is the GeoAI. In terms of GeoAI, as it is the combination of artificial intelligence and the geospatial technology, which collectively known as GeoAI. So Geo stands for geospatial, AI stands for artificial intelligence, and the integrated term is regarded as GeoAI. It represents an evolving transformative approach to climate change mitigation. Individually, each technology offers distinctive capabilities. AI brings advanced data processing, machine learning, and predictive analysis. So individually they do different functions. So as we just discussed, AI brings advanced data processing in terms of machine learning and predictive analysis, whereas the geospatial technology in terms of remote sensing, GIS and other tools, so GNSS and the IoT tools, it provides accurate spatial insights into the environmental conditions or the climate conditions and climate change. So in that sense, you can see here from the left hand side, the depiction is with respect to the data collection, storage and assemblage, the first component. The second is once this is done, a problem is identified. The second is GeoAI analytics in terms of real-time modeling. So where both the geospatial and AI-based analytics is needed. The third is, with this understanding system function and reliable prediction, third is GeoAI scenario simulations, multi-objective optimization and smart decision making that helps in terms of scenario assessment, management, plan design and implementation. The fourth is a kind of web-based geo-visualization. Once you get the data, you know the information in terms of that you want to see it. So it's a geo-visualization, stakeholder engagement and early warning. So it helps in terms of finally monitoring, evaluating and management planning. So in terms of the inside figure, you can see the various components: LiDAR, the IoT devices, the UAS in terms of Earth observation system. Down below you have the GNSS, the UAV. So data is coming from various observation systems. So this data actually is being utilized by the using the AI and machine learning tools in a geospatial environment. So that is what in the integrated way we call the synergies harvested between the AI tools and the geospatial tools. So we call it GeoAI, that helps in enhanced climate solutions. So GeoAI leverages the AI's data-driven intelligence with the spatial precision of geospatial data. You can see the geographic data in the depiction down below. Then the other data sets such as biodiversity data, land use data, cultural and administrative data, all these data sets are there. So in this data is utilized using the artificial intelligence tool. So that we call that it uses the GeoAI technique. So innovations like cloud computing, edge AI, satellite constellations are enabling the real-time data collection and analysis at scale, improving our understanding of environmental patterns and making the GeoAI even more impactful. For example, if we integrate AI with high resolution satellite imagery, it helps or it enables the real-time monitoring of various climate or climate change related activities. Similarly, advancement in other tools such as which fall under the broad framework of AI, such as machine learning and deep learning, that allows AI to analyze multi-source geospatial data from sensors, drones, satellites, providing detailed insights into areas such as carbon levels, air quality. So, by enhancing the predictive capabilities with location-based data, GeoAI can foresee climate impacts more accurately. That is how it adds proactive measures such as early warning systems and targeted resource allocation. So these two references have been used for preparing the slides. So finally, coming to the conclusion, we discussed about AI. It is definitely a cross-cutting tool. Geospatial technology, that also is a cross-cutting tool. They have utility in terms of analyzing lot of data and data in the spatial scale. We discussed some of the examples as far as the Earth system model is concerned, as far as the grid level integration is concerned, as far as the solar energy production is concerned, and also in climate action. So these are the examples we have taken to understand and realize the utility of AI and geospatial tools, and together we call them GeoAI. So GeoAI leverages the AI's data-driven intelligence and the spatial precision of geospatial data. So this is going to be the future in terms of integration of the data intelligence tool coming through AI and a lot of spatial data coming from the geospatial platform. So that is how the GeoAI is one of the important cross-cutting tools useful in climate action as far as mitigation and adaptation is concerned. Thank you very much.